In this video, we are going to be talking about rationalizing denominators with two terms. So we have talked about rationalizing denominators with one term in previous videos. This is specific to two terms because when we multiply with two terms, it gets a little bit more complicated. So the question is, how do you get rid of that radical when you're multiplying with more than one term? And the answer is conjugates. Just like when we multiplied something like a plus b times a minus b, we would end up with a squared minus b squared, right? A difference of squares. The middle term completely drops out, and we end up with two perfect squares. So when we square a square root, we're going to lose the radicals, and that's why the conjugates work. So, for example, we have 5 divided by the square root square root of 2 plus 1. So here's one term plus another term, two terms. You cannot just multiply by the square root of 2. If you tried, this one would go away, but now you've got a 1 with the square root of 2. So you cannot just distribute a square root of 2. You have to multiply by a conjugate. Conjugates are the exact same terms, so square root of 2 and a 1, but with different signs. This was a plus 1, I'm going to put a minus 1 there. Whatever I do in the denominator, I have to multiply by the exact same amount in the numerator to keep it equal. In the numerator, I'm just going to distribute. So I end up with 5 times square root of 2, which is just 5 square root of 2, and 5 times negative 1, which is negative 5. In the denominator, I have to FOIL or box it out, or I can use this shortcut. I know that conjugates are going to multiply into a difference of squares. But let's just see what that looks like real quick by multiplying using the box method. I have square root of 2 plus 1 times square root of 2 minus 1. Square root of 2 times square root of 2 will be the square root of 4. Square root of 2 times negative 1 is negative square root 2. Positive 1 times square root of 2 is just square root of 2. And positive 1 times negative 1 is negative 1. We have plus square root of 2 minus square root of 2. Those are 0. That's the whole reason we multiply by the conjugate, is we lose that middle term. And we're going to lose those radicals because the square root of 4 is 2. We have that minus 1, and 2 minus 1 is just 1. So all of that is over 1, which is just 5 square root of 2 minus 5. So when we rationalize that denominator, we actually ended up with a denominator of 1, which is just itself. Go ahead and try the two examples on the right. So conjugates are the exact same terms. The signs in the middle are different. Whatever you multiply in the denominator, multiply the same thing in the numerator. If it's one term, you can distribute. If it's two terms, you need to box or FOIL. Alright, example A on the right. What is the conjugate of 7 minus square root of 2? Did you guess 7 plus the square root of 2? You'd be right. Again, exact same terms, the sign in the middle changes. So this was a minus sign in the middle. We're going to change it to a plus sign. I multiply by the same thing in the numerator. So that sign doesn't change. We take the opposite sign of what we started with, but when we multiply numerator and denominator, it's the exact same thing. Alright, we distribute. 3 times 7 is 21. 3 times square root of 2 is 3 square root of 2. In the denominator, I'm going to take a moment to write it on a different sheet of paper. So we're going to multiply out 7 minus the square root of 2, and 7 plus the square root of 2. 7 times 7 is 49. 7 times the square root of 2 is 7 square root of 2. 7 times a negative square root of 2 is negative 7 square root of 2. And a negative square root of 2 times a positive square root of 2 will end up negative square root of 2 times 2, which is 4. Plus and minus 7 square root of 2 is 0. I'm left with 49 minus square root of 4 is 2. Subtract and we get 47. So that's going to be our denominator here. So over 47. So you might see it written this way, or you might see it broken up into 21 over 47 plus 3/47 square root 2. Either way, those are equivalent, right? We're dividing each term by 47, or we're just leaving it as one big fraction. All right, part B here. What is the conjugate of square root of 3 minus square root of 2? It's square root of 3 plus square root of 2. Multiply the same thing in the numerator. All right. So this one's got a lot going on. We have 5 plus the square root of 2 in the numerator times square root of 3 plus square root of 2. So I'm going to go ahead and, again, make some more room, do it on a different page. I said, let's see, draw my box. We have 5 square root of 3, or sorry, let me look at that again. 5 square root of 2 times the square root of 3 plus the square root of 2. And again, let me make sure. Yep, okay. Now we multiply it together. 5 times the square root of 3. 5 times the square root of 2. Those are easy, right? Because 5 is not under a radical, stays outside. And then square root of 2 times the square root of 3. They are both under the radical. 2 times 3 is 6. Square root of 2 times square root of 2 is 4. Now I have 5 square root of 3 plus 5 square root of 2 plus square root of 6. And then square root of 4 is going to be 2. I'm going to go ahead and write that in my numerator. So 5 square root 3 plus 5 square root 2 plus square root 6 plus 2. None of those are like. There's nothing I can do more with that. And none of those radicals can be simplified. Now to multiply out the denominator. I'm going to make another box. I have square root of 3 minus the square root of 2 times the square root of 3 plus the square root of 2. Square root of 3 times square root of 3 is going to be the square root of 9 because of that 3 times 3. Square root of 3 times square root of 2 is square root of 6 because 3 times 2 is 6. A negative square root of 2 times square root of 3 is negative square root of 6. And then lastly, a negative square root of 2 times a positive square root of 2 will be negative square root of 4. Plus and minus the square root of 6 is 0. And then we have the square root of 9, which is 3, minus the square root of 4, which is 2, and 3 minus 2 is 1. So our denominator would be 1, which means our final answer is just the numerator. Anything divided by 1 is itself, right? And there you have it. So did you see the pattern? Did you recognize the pattern of the a plus b times a minus b is going to give us a squared minus b squared? So if you did, you don't have to box it out for the denominators. I would just end up with 7 times 7 is 49. The negative square root of 2 times square root of 2 would be negative square root of 4, which is just 2, minus 2. Same thing here. Square root of 9 would be 3, minus the square root of 4 is 2. So you just square the first term minus square the second term, right? Difference of squares. And there you have it.